Hello everyone, welcome back. So today we'll discuss about a topic that is electricity, and this topic we'll discuss keeping in mind for the class 10 students. So class 10 term 2, this is in the syllabus. The chapter is in the syllabus, that is electricity, and one more chapter is there, that is magnetic effects of electric current. So both the chapter I'll discuss. So first this chapter. So from physics part, these two chapters will come in term 2 exam. Uh, you might have completed your term 1 exam recently. So this chapter will be in the term 2. So you should prepare this chapter thoroughly. So this lecture, this video, I'll complete the whole chapter, and basically basic concepts and all the formula I'll complete within this video. So you can if you find any doubt in this chapter, you can write in the comment box, so I can try to I can make another video clarifying your doubts. I'll check it if possible. So this chapter electricity, it will start with the flow of charge. As we know that the current, the flow of charge is called rate of flow of charge is called current, and it is defined as your I equal to Q upon T. Q is the Q is the charge and T is the time. So Q upon T is the rate of flow of charge, is called your current. This is your rate of flow of charge, rate of flow of charge, right? So what will be the unit, right? Unit we can write from the formula itself. The charge unit is coulomb, so its unit is C. Coulomb we represent with symbol C, and T with second. So your I, we can write coulomb per second, or a standard unit is there, that is the current unit is SI unit of current. SI unit of current is ampere, and symbol is capital A. So capital A is defined or represented for the current I, right? This is the unit of your current. Now Q is the charge and its unit is coulomb. Coulomb is the name of a scientist, so according to his name, so coulomb is C is taken as the unit of your charge. So you should remember these things. One mark short question, one mark type question may come in the board exam. So the next point is your work done and your potential difference. So potential difference V equal to W by Q. What is that? Potential difference between 2 points is the amount of work done to transfer one unit of charge from one point to another point. This is your potential difference. So V is W by Q, and your V, the unit is represented with volt, and symbol B. B is the symbol for volt, and W is the work done. Work done is, what is the unit of work done? Work done is represented as joule, and Q again the unit of is C, coulomb, right? So this is also one formula for formula number 1. Let's say formula number 2, your V is equal to W by Q, or W equal to VQ, right? So this is very important for your exam point of view. So the third one is the Ohm's law. So Ohm's law states that your voltage is proportional to current, or V equal to IR. This is your Ohm's law. Ohm's law, right? So Ohm's law said that V is proportional to current I. That means if the voltage will increase, then the current will increase. You can draw like this: Pi So it will be a directly proportional, means it will be a straight line. The graph will be a straight line. So voltage will increase, the current also will increase accordingly, and R is the proportionality constant, or this is resistance. R is resistance, and R unit of R is SI unit is in ohm, OHM, or this type of symbol also used for the unit of your resistance R. This is your resistance. R is resistance. Now this resistance of a material depends upon certain parameters, like if this is a conductor, right? So resistance depends upon its area of cross section, its length. If more will be the length, more will be the resistance. If area of cross section will increase, the resistance will decrease. So R, these are the factors affecting resistance. Factors affecting resistance. So R depends upon your length of the conductor, that is R proportional to L, R inversely proportional to area of cross section. And if you will combine both, right, if you will combine both, then you can write R equal to rho L by A. Rho is a constant, proportionality constant, and it is called resistivity. It's called resistivity. What is the unit of this resistivity? If we'll cross multiply, this is ohm, this is meter square. So in the denominator, meter will be there, meter will come here. So ohm meter. What is the SI unit? Unit is ohm meter. This is the symbol for ohm, OHM, ohm. I have written already. The symbol is either this or ohm, OHM also we write. So ohm meter is the unit of resistivity. Units are very important. Sometimes 1 mark question comes from the unit, and also if you are solving a numerical, if you are not writing the unit properly, then also half marks can be deducted. So accordingly you should plan, and you should know the units also. This is very important. So this is the factors, these are the factors affecting your resistance. Now the next thing in this chapter we'll discuss about this resistance. If we'll join in series or in a parallel combination, then what will be the result? Find there will be the net resistance, that one will calculate. But before that, let me explain that whether this B is proportional to I, will it obey for all materials, all temperature? Is it so? No. B is proportional to I, voltage will proportional to current up to a certain temperature, up to a for different material it is also different. Beyond certain temperature also it will not obey. All this discussion you will learn in class 12. So for now you remember that B proportional to I up to a particular limit. Beyond that limit, this will not obey Ohm's law. So Ohm's law also some means materials will when it will go beyond the limit, it will not obey the Ohm's law. Now the next part is resistors in series. So resistor, if we will represent with a symbol, so this is a symbol for your resistors, right? So if we'll connect resistor in series, so we'll discuss first series connection, then we'll discuss the parallel combination. So if we'll join the resistors in series, this is a series combination, and a battery or cell, right? The longer line is positive, the shorter line is negative. This is the standard representation, and current direction is always from positive to negative. So this will be the direction of current, and in a circuit if there is no branching, then the same current will flow through the circuit. So same I will flow through the circuit, here also same current, but there will be different voltage drop. So here the voltage drop, let's say V1, here the voltage drop is V2. But you remember that the sum of this voltage drop will be equal to the source voltage V. So let's say the source voltage V, so V will become equal to V1 plus V2. Now what you can write, V, suppose the current I is flowing in the circuit, so you can write V equal to, from Ohm's law, V equal to IR. So you can write this IR equal to V1 will become, this is, let's say, R1, this is R2. So V1 you can write same current flowing, so I will same R1 plus IR2. Now you can take I common, this is R1 plus R2. So this is your IR, I cancelled out. So you can write R equivalent, this is equivalent resistance, net resistance of the circuit, right? So equivalent resistance R equivalent equal to R1 plus R2. Now if you add more resistances, then simply R2, R3, R4, like that you will add on, keep on adding up to Rn. So general formula you can write R equivalent equal to R1 plus R2 plus R3 plus Rn. This is the general formula for equivalent resistance when these resistors are connected in series. Now let us discuss for parallel case, parallel combination case. If resistors are connected parallelly, then what will happen? I have told you that if there is no branching, then same current will flow. But if there is a branching, then Kirchhoff's law will come, you will learn in class 12. So there will be branching. That means the outgoing current will be at a junction point. The outgoing current will be, sum of outgoing current must be equal to sum of incoming current. So here incoming current is, let's say, I. Outgoing currents are, let's say, I1 and I2. So the sum I1 plus I2 must be equal to I. Fine. And voltage will remain constant in parallel combination. So here also V, here also V, here also V. Voltage will remain same, but there will be division in the current. So current will be divided. So we can write that, we'll begin with this, that I equal to net current, I equal to I1 plus I2. So we'll begin with this. So, and we'll write this one. So all these concepts, I hope that already you have studied. Just this is a revision and the clarification of your basic concepts. So some of the questions I'll discuss in the next videos. Fine. So what we have done, we are writing that I equal to I1 plus I2. Now you see, same V and R resistors are different. Let's say this is R1, this is R2. So what I'll write for I know that from Ohm's law, this is V equal to IR. So my I equal to V upon R. So I1 I can write, this is V upon R1, same voltage, and I2 equal to, I'll write V R2, and this I equal to V upon R. So what I'll do, V all in the numerator, I'll cancel it out. So this is my R equivalent, and this is total voltage, this is total resistance. So my 1 upon R equivalent equal to, my 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2. So this is my net resistance or equivalent total resistance when the resistors are connected in parallel. More resistance, suppose third resistance is connected, so 1 upon R3 you will add it, right? So lots of problems are there, series and parallel combination. So I'll discuss them in the next classes, next videos. Right, so this is your equivalent resistance. Fine. Now we'll proceed to discuss for the power, right? So the next part of this your chapter is power. So what is power? We know that power is the rate of doing work, right? W by T. Power is W by T, or so we can write like this, P equal to W by T, and W we know that from your potential difference concept in your this chapter. So B equal to potential difference equal to B equal to W by Q, or W equal to BQ. This is what we have discussed at the beginning. So W I can represent, this is VQ and this is T. So Q by T, again I know it's I, right? The first formula we have discussed, the rate of flow of charge is current, so I can write VI. So this is very important formula, that power equal to VI. Power equal to VI in electricity, power equal to VI voltage into current. Suppose voltage, power is written, most of the electrical appliances, what is the watt, right? It's a 10-watt bulb, it's a 100-watt bulb. So W watt is written, power of each electrical appliances is written on it, means you can see it in and the leveling of any electrical appliances. So power equal to VI. V is the potential difference and I is the current flowing through it. So the relationship is this one. Now in numericals, when we will solve different type of problems, we need this power in different form. Like you can convert this one. Suppose this is formula number 1 for power. Formula number 2, I can write V equal to, from Ohm's law I know that IR. So from Ohm's law I can write IR into I, so it will become I square R. So power is I square R. Also second formula, one more formula, and another formula also you can write, that is P equal to VI. So I equal to, from Ohm's law again, V upon R. So V, this is V upon R, or you can say V square upon R. So power, another formula is P equal to V square upon R, P equal to VI, P equal to I square R. So three formula I have written for your power, and unit of power is of course watt. And so you should remember all these three formula. Sometimes what happens in the numerical, current will be given, resistance will be given, you have to find out power, voltage is not given. So what you will do, either you can go to the Ohm's law and you can find out a voltage and you can use this first formula, or if you remember this directly you can find out the power, right? And from the power concept we will discuss another one, that is heating. So heating will come up. You know in your junior classes like class 7 and 8 that what is Joules law of heating or heating. When electric current or charge flow in a conductor, we know that it gets heated, right? So when it gets heated, some of the energy will be dissipated in the form of heat. So how much heat will be dissipated? So it will be dissipated in the in terms of energy. So we know that energy equal to your W, that is basically, so P equal to W by T, or W equal to your work done equal to E equal to basically PT. Now this is the energy we are calculating basically in the form of heat, right? So energy is PT, and P we just derived P equal to VI. So we'll write this is VIT, right? And V, or you can directly write P equal to I square R also. So V equal to IR basically. So in terms of resistance, if you want to write it, it will become I square RT. So your E energy is I square RT. So this is called Joules law of heating. This is called heat energy also, E, or heat energy, right? So this is called Joules law of heating. This is Joules law of heating, right? So Joules law of heating says that generally this law is very much very important and used in many of the appliances like your room heater or geyser or iron, right? So in these appliances where heating effect is used, so generally the engineers, they play with this R, they play with this resistance. So different material they use, where they increase the resistance or they use a variable resistance, so you can change the heat, we can get the heat energy out of that appliance. Suppose heater is there or iron is there, so a coil is there inside it, and we use high resistance material generally, so that we get more amount of heat out of that iron, or some knob is there, so we can rotate and adjust in such a way that this resistance value we can increase or decrease, so that we get more or less heat energy out of a iron. And we generally do not play with I, because if current will very high amount of current will flow in any of the apparatus, it may damage, so it may create problem. So generally whatever current is flowing in the circuit, we generally do not increase or decrease decrease the current. What we do is we generally play with the resistance R, and we get different amount of heat energy. So this one is also used, this principle is used in the fuse. Generally you may have seen near your meter box. So in the main supply a fuse is there. Suppose some extra current comes from the main supply, then what happens, your appliances, television, refrigerator or other appliances in your house, it may damage. So to protect your household appliances from the external extra current, what can be done, the fuse is there. So when extra current will pass, this H equal to I square RT, this formula will work. So I is more there suddenly, and some material is there which is having a low melting point, so it will melt quickly. It will some heat, so when extra current will come up, heat energy will be there, it will be heated and the material will be melted. So in this technique fuse is used to protect the household appliances, but nowadays this fuse is replaced with miniature circuit breaker, MCB, right? When extra current comes, it fall down, or extra load is there, it also fall down, right? So you might have seen now in modern days we are mostly not using the fuse, we are using MCB. So after this, the last part of your chapter is about the commercial electric bill, or you can say unit, right? So one commercial unit is electricity unit that your meter box reads. Generally you pay the bill monthly, so it is 1 kilowatt hour, 1 kilowatt hour, kWh, right? When it consumes energy amount 1 kWh, then your meter reads 1 unit. So 1 kilowatt hour, if you convert to your watt second, then kilowatt means it is 1000 watt, and 1 hour to second is 3600 second. So basically it will be 3 to 5. If we convert 3.6 into 10 to the power 6 joule, right? So 1 unit is this much of joule. So this is your commercial unit. So when 1 kilowatt hour energy is consumed, right, kilowatt hour energy is consumed, then your 1 unit will be there. So many question comes from this concept, like the question comes like, suppose you are using 5 bulbs, 1 television for a month of April, like or 30 days. So how much energy or how much bill you will pay at the end of the month? Let's say the per unit cost is 5 rupees. So you can easily calculate. You can first calculate what is the energy consumed. So energy is PT, right? This formula you will use, power into time. 30 days you will calculate in hour, then you can find out in kilowatt hour how much energy you are consuming. So suppose you got 10 kilowatt hour, your final result you got. So 10 kilowatt hour means 10 unit you are consuming. So 5 rupees per unit cost. So 10 into 5, 50 rupees you are going to pay, like that. So it may be more, I'm just giving you one example. So like that you can calculate the amount of amount you are going to pay the electricity bill at the end of the month, using this formula, using this commercial unit. So this is unit, or this is the exactly this is a commercial unit. This is commercial unit. So all these things are there in your chapter number 1, and this is what I have discussed, all these formulas in one video, and you can say briefly one formula at a time, so that you will not get confused with all these things. Still, if you find in any concept you have some doubts and you are not very clear in any concept, you can write in the comment box, so that I can explain it again for the later, if time permits for me. Right? See you in another video. Thank you for watching. Bye bye.